This is worksheet 9 and 10, and you need a graphing calculator. We're going to do box and whisker plots, and we're going to do histograms on the calculator today. And because of the homework check, I'm going to start out right away. All right. This says that in lesson 08, thank you, which would have been August, okay? We didn't actually even do lesson 08, but we talked about some things in chapter 0. I'm not even sure we even did this, but basically what they're saying that you should remember are things that deal with one variable data, which would be the mean, the median, okay, the mode, and the range. Does everybody remember what all these mean? The mean is you just average the numbers, right? The median is the middle number. If you have 5 numbers, it's the third one, but if you have 6 numbers, you have to take the 2 middle ones, add them together, and divide by 2. Pretty good? The mode is the most often occurring answer. So if the list was 1, 2, 3, 4, 5, there would be no mode. If the list was 1, 1, 2, 2, 3, 4, 5, then 1 and 2 would both be modes. Okay, if it was 1, 1, 1, 2, 3, 4, 5, then 1 would be the mode. We good? Range is just maximum minus minimum. Everybody okay with all those? All right. To determine which summary statistics you should, okay, then they talk about a 5-number summary, my bad. Okay. The 5-number summary is the min, Q1, which is the 25th percentile, the median, Q3, and the max, okay? And both of those, all of that, can be found on the calculator. I'll show you in a minute. But to determine whether you should use the mean as this measure of central tendency, okay? And then the spread, you can either use the standard deviation or the 5-number summary. And to determine which, they say you should look at the shape of the data, and we're going to do this on the calculator, but you have this in your notes as well. All right? When most of the data, so if you drew a line through the middle here and most of it is over here, this is called negatively or left skewed. The book largely calls it negatively skewed, but I used a test generator to write the quiz, and it uses left skew, so make sure you understand both, okay? Symmetric is anything where you could like draw a line of symmetry and both sides look the same. Positively or right skewed, okay, means that through the middle, most of the data is to the left. There's not much to the right. I always say to myself, this is like it's screwed up on the right, okay? There's not much out there on the right. Now, before I do this, I want to talk about, these are box and whisker plots. You've seen these before as well. Okay? This is going to be your min, Q1, your median, Q3, and your max, and you'll be able to trace and find those values on your calculator. But if the left whisker is longer, it's negatively skewed. If the right whisker is longer, it's positively skewed, okay? That means that this 25% is way spread out, or this 25% up here is spread out more. All right, just covering that while we're talking about that. When you're choosing which to use for the measure of center and spread, if the distribution is reasonably symmetrical and doesn't have outliers and like there's one point way out away from the rest, use the mean and standard deviation. If it is skewed or has outliers, use the 5-number summary, because the 5-number summary will throw outliers out separately. And we'll talk about what an outlier actually is in a minute. All right. This is a set of data that we are not going to spend time typing into our calculator, because I'll be here all day. You know how fast I am. Okay. But I included this example because here are the keystrokes. Okay, to get a histogram on your calculator, it says you would type the data into list 1, you would turn on the stat plot, which is second y equals, then you would select the one that looks like a little bar graph. We're going to do this with a different set of data in a second. Then you could hit zoom stat to set up a window, or you can set it up by hand. The X scale is what will determine the width of your bars or your categories. So if you wanted to count from 4,000 to 35,000 and have your bar be 4,000 to 5,000, 5,000 to 6,000, 6,000 to 7,000, you would say your X scale for 1,000. Okay. This graph, when they graphed it, which they say they did a zoom stat, I didn't get exactly the same graph when I did a zoom stat with this data, so I think they're a little crazy. But do you see that there's very little over here on the right? So this is skewed right. Okay. It is positively or right skewed. Therefore, remember this slide we just talked about? Come on. Okay, if it's skewed, use the 5-number summary. Everybody see what I'm talking about? So they said this was skewed, so then they did this one variable stats, which is stat right arrow choice 1. And then you're asked to describe this, summarize the center and spread. So if you're using the 5-number summary, no matter which you're using, you need to give a couple sentences. This is the number of passengers who boarded planes at 36 United States airports. So they said the number of passengers ranges from, and they gave the min and the max. See where they got those numbers? The median number of passengers is about this, rounded it to the nearest passenger. Half of the airports had between this many and this many passengers. Half are between Q1 and Q3. So they said half of the data lies between these two numbers, Q1 and Q3. Okay, that was their summary. We're going to do something similar with our stakes. Okay, so I don't think I can use, well, I don't know, maybe I can use this one. I can make it small enough. All right, so we're going to go stat, enter, clear out list 1, not delete, remember up onto the title, clear, enter, and put in these numbers. Okay, I hope this will work. All of them go in list 1. Do not put part of them in list 2. Had trouble with that earlier today, misunderstanding directions, my bad. All right, proofread your list, which for me is a necessity because I'm pretty sure I screwed something up here. You have to know how to do this without asking me 15 questions on the quiz, so please be doing this. This is a muscle memory thing, okay? You'll remember how you did it if you do it yourself. Everybody got it? Okay. We are going to turn the stat plot on. You do need to be in function mode, or the window will ask you some crazy stuff, okay? So go mode function, second y equals, hit enter so that it says stat plot on. Make sure that the box is darkened around on, not off. How we doing? Second y equals, stat plot on. Then you're going to arrow down and you're going to choose the type that looks like a little bar graph. Mine's the third one over. Does that seem right for everybody? No matter which model calculator you have. Now, you want it to say list 1. And frequency, we're not putting a frequency list in, so it just says frequency of 1. In other words, each item in list 1 occurs once. All right, I'm going to go to set up a window by hand rather than using the zoom. What's the smallest stake? What size? 17? Okay. Now, what's the biggest stake? 21. I'm actually going to put 22 here because it's going to start the category at 21. I want it to go to 22. Thanks. Then my scale, I'm going to put 1. I want each bar to represent between 17 and 18, 18 and 19, 19 and 20, 20, 21. Okay, how many were in each category? Now, my Y window, I'm going to do like, I don't know, -2 to 10. You can do a zoom stat, but I don't really like the categories they pick. Okay? Now, if you do trace, it will say, hello. It says my minimum is 17 up to values less than 18. So all the 17-ounce stakes are represented there, and it says N is 1. Means there's 1 stake in that category. If I move it over, I get 4 stakes in the 18-ounce category. How we doing? Anybody have a question? Didn't work? Philip?
Why did you choose to do 22?
Because if I do 21, it cuts off at the category at 21. I'll show you. If I change this to 21, yeah, you don't see that it says the 21 and above category isn't there. So it doesn't give you that bar. So because that was 17 and above, and our minimum was 17. Okay? If you look, if you hit trace, I don't know why this keeps pausing when I hit trace. When you hit trace, see it says 17 to numbers less than 18. This category actually goes up to 21. And so it cuts off there. If I want it to go all less than 22, I have to go out to 22. Again, you can do a zoom 9 and you'll get something like this. It just won't be exactly the same. This one I think is easy to understand. All right, do a really rough sketch, guys. There were 17, 18, 19, 20, and 21 ounce stakes. Yes? If you do a zoom 9, you get a gap. I don't know why. It sets a... It counts by halves or something weird.
Your scale is 0.8.
Yes, yes, which makes no sense to me that the scale would be 0.8. So, all right, there was 1 stake here. 18 was 4. Is that right, guys? 19 was 5. Then it goes up to what, 8? And back down to 2. I'm just doing a really rough sketch, okay? Histogram is graphing the frequency of data points found in each category. This one is skewed what? Left. Okay, I will be honest. The whisker thing makes more sense to me, so sometimes I just go back here, go to my stat plot, go down here, and I choose the 4th one over, which we're going to do in a minute anyway. And I go zoom 9, and I go, oh, the left whisker is longer, therefore it's left skewed, okay? So if you want to do that one instead. But what we need to do now is find either the mean and standard deviation or the 5-number summary. If it's skewed, we need what? 5-number summary. Either one is found under the 1 variable stats. So go stat, right arrow, enter. You do not want a frequency list, So you need to clear out that frequency list if your calculator offers that option. If it's an older calculator, you just hit enter because it's only going to assume you want list 1. Don't put list 1 comma list 2 is what I'm saying. All right, so I have a mean of 19.3. Did anybody get that? Okay, the difference between this and this is a sample standard deviation, which we're really not going to talk about anyway because it's skewed, but the sample standard deviation versus the population standard deviation. I'm not going to be picky. There is a question on the quiz that asks for both. It's a multiple choice question, so you just pick the one that matches the answers here, okay? But this is not every steak in the world, correct? So if we wanted to talk about the standard deviation, we'd want to use this sample standard deviation, okay? So the standard deviation, anyway, was just a little over 1. All right, this is where you have to scroll down. And now you have our 5-number summary that we want, okay? Q1, the min was 17. Q1, or the 25th percentile, was 18.5. How am I doing, guys? My bifocals aren't happy with me here. The median is 19.5. Q3, which is the 75th percentile, is 20. And the max is 21. All right. Also, if you do a stem and leaf plot, like I did here, I turned this kind of a graph on, remember? When you trace, it will tell you min, Q1, median, etc. Okay? We're going to do one of those in a minute anyway. We're supposed to write a couple sentences. Okay? First of all, why are we going to use the 5-number summary? Yes. Use 5-number summary. Oh my goodness, this is the worst writing ever. That's supposed to say use, because the data is skewed. Okay. Now, we need to write a couple sentences like they did earlier. Anybody tell me anything using our 5-number summary? Okay. All of the steaks were between what? The median was 19.5 ounces. And how about the middle 50%? 50% of steaks weighed between what? 18.5 and 20 ounces. I'm not too sure how I feel about their advertising a 20-ounce steak. They're falling a little bit short, right? The median was a little bit less, but there was as many 20 and above as there were below, so anyway. All right, another term besides skewed and symmetric is uniform. If you happen to have a graph where everything, all the bars are exactly the same, that would be considered uniform, okay? Another one that we are not going to, I did not pick any on the homework that was this way, but it's called bimodal, okay? Bimodal data is like, for example, if everybody had a really strong opinion about something, so we had a lot of 1s or 5s when we ranked it, or a situation like this, where they've put in all these colleges, the cost of going to college, and they got this. Why do you think there could be a whole bunch of them down here and another whole bunch up here, if these are just random colleges? No ideas? Like, these could be public universities, right? Tend to bunch together and be close in price, whereas private colleges are usually higher, more expensive, and if you grouped all those, they would bunch together. Okay, that's just a reason why it could be bimodal. All right, we're not going to spend too much time on that. Box and whisker plots. One reason to use these is when you're comparing two sets of data, the calculator will let you do one plot for list 1, one plot for list 2, and compare them. So that's a nice feature of this. All right, we are going to do one by hand. This is the dorkiest set of data ever. So the shoe store employee designs a display by placing shoe boxes in 10 stacks. The number of boxes in each stack are, but I want us to practice just once doing one of these by hand so you better understand what a box and whisker plot is, okay? First thing you do to plot these numbers is you put them in order. It goes 5, 5, 7, 7, 8, 9, 9. I've done this 3 times today, so I'm pretty sure I got this right. And then 10, 11, 13. Okay? You normally wouldn't have to do this. By the way, what's the mode of this? 5, 7, 9 are all 3 modes. Okay? It's called multimodal. All right. We're going to do by hand a box and whisker plot. That means you need to find the median or middle number. Is there an exact middle number here? If we have 10 stacks, no. So we're going to say right in here is the middle. So you tell me average these two, you get 8.5. That means half the data is below 8.5, half is above. Everybody okay? It's the definition of median. All right. Q1 is the middle of the bottom 5. What's the middle of the bottom 5? So this is Q1. This was the median, by the way. Okay. What is Q3? The middle of the top 5. And the min is 5, and the max is 13. What is the interquartile range for this question? Did I not even talk about that yet? It's Q3 minus Q1. In other words, how wide is it between here and here? So it's 10 minus 7 is 3. Sorry. All right, we'll talk more about that in a second. To do this by hand and draw a little, you would need a scale, okay? So if I start this at 5 and I just mark off evenly, there's 6, 7, 8, 9, 10, 11, 12, 13. You want a nice scale. Then to use the numbers from our question here, our first whisker starts at 5 and it goes to 7. Then the box starts and it goes to 8.5. So this was 7, 8, 8.5. That's a quarter of the data in that part of the box. Then from 8.5 to 10 is the other half of the box. And the whisker starts from 10 and goes out to 13. What do you think about skewed or not? It's slightly skewed what? Skewed right, because the right whisker is longer. Okay? Most of the data is to the left, very little to the right. The longer whisker means, well, there's 25% in each portion of this. This 25% is more spread out. When it's skewed right, we have to use what kind of a summary? 5-number summary. Did we already find the 5-number summary? Okay. I really don't want to spend a lot of time on this, but if you typed these in to the list, okay, and then you went stat, well, you would go second y equals, and you would turn on, all right, we're going to do it really fast. Go stat, enter, type these into list 1. You can type them in any order. So if you want to do the 5, 5, what was it, guys? 7, 7. Okay. Go to stat plot and just go back to the first one, which should already be turned on. You want the fourth one over. It looks like a little robot head with something flying out of his ear. Okay? That one will determine outliers. The one on the right, just to the right of it, would also be a box and whisker, but if there happened to be an outlier, it wouldn't tell us. This one will. All right, make sure it says list 1, and then go ahead and do a zoom 9. Is the right whisker a little bit longer? Okay, now trace, because I want you to see that the calculator would have told you immediately, min, trace to the right, Q1, median, Q3, and max. Okay? You can also find those by doing what? Stat, right arrow, one variable stats, and then scrolling down to the bottom, right? And it would have listed them. Everybody good? All right. Can I skip writing a big paragraph about the size of the stacks of our boxes?
No.
Since we just don't care, right? All right, I need you to write this down, particularly the interquartile range. All right, we'll talk more about outliers tomorrow, possibly, but you need to know for the quiz how to find an interquartile range. So make sure you know that that means you just take Q3 minus Q1. And there is a typo on the slide for all my little eagle-eyed English people. There we go. If a data point is more than 1.5 times that interquartile range outside of the quartiles, then it is considered an outlier. Basically, this is what you need to know. Neither whisker can be more than 1.5 times the length of the box. If the whisker's too long, you throw that data point out. It's called an outlier. And then you only connect your whisker to the point before that. Yes.
So if there's an outlier, you see that before you even enter it into your calculator, do you just not put it into that?
No, because it will change the mean and median and stuff if you don't even enter that data point, okay? Unless it specifies not to. It might on one of the worksheets, I can't remember. It says throw out the outlier. Everybody got what they want off here? IQR is interquartile range, which is Q3 minus Q1. That's the most important thing on that slide, because I know that's on the quiz. All right, I want us to enter this in. I want you to enter all of these data points into one list on your calculator. I'm going to go off the cuff here, and I'm going to tell you, for now, just enter them all in. I'm going to try something different than I did last period for part of this, but for now, just enter them all in. So stat, they're on your worksheets. I'm going to do two different things with this, so please be entering these. These are wind speeds in a bunch of different cities. There are 21 of them, so you should have 21. Should be looking for your 22nd data point if you're at the bottom of your list. You can proofread them quick. Make sure you don't have anything too wonky. I hope mine are right. All right. I'm going to do, does it ask us to do a histogram first? Okay. So let's be lazy and do zoom stat, okay? So turn on the stat plot. But I don't want a box and whisker this time. I want the little bar graphy thing. And then once I have that, I'm going to just go ahead and do zoom 9 and let it pick the window this time. I went with this is kind of just symmetric. What do you think? Sometimes I told you this already, if I'm being lazy, I go in here and do the box and whisker plot to double check, because if the whiskers are longer, that will tell me the same thing. If I do that, the whiskers look roughly the same length, yes? Okay, so I'm going to go with it's symmetric or more so than any skewedness. All right. Then we need to use what to find our measures of center and spread? Mean and standard deviation, not the 5-number summary this time, okay? So we're going to go stat, right arrow, one variable stats, no frequency list, and we're going to say the mean wind speed was what? Anybody get it? 9.2 miles per hour. Was it miles per hour? Yes, it was. Okay. With a standard deviation of, I would say this is a sample of cities, so 1.6, though if you used 1.5, I wouldn't count it wrong. I'm not going to be picky about that. The standard deviation is how far the spread is. Most of the data, 68%, when we get to normally spread data, is going to fall within one standard deviation either way. Okay? A small standard deviation means the data was lumped close together. All right. The second thing they want us to do here, we kind of did both of those already. I need you to be paying attention. They want us to change our mind and make this into 2 categories. What we're going to do is go through and delete from list 1 the ones near an ocean, okay? Baltimore, Los Angeles, Anchorage, Boston, Honolulu. Now, I think they screwed up. Wouldn't you say New Orleans is on an ocean?
Yeah.
Okay. And then at the end here we have Miami, New York, and Seattle. Okay? So, we are going to delete all those. Make sure you do New Orleans as well. From list 1. Oh, wrong calculator. So I'm going to go stat, enter, and I'm going to delete those. And then go and put them in list 2, guys, when you get done. Whoops. I'm supposed to be deleting. Here we go. Put the starred ones over into list 2. Now you're going to have to retype them. Make sure you include New Orleans this time. And honestly, I don't know what this is going to look like because, like I said, I just realized last period that we probably should put New Orleans by the ocean. So I'm going to arrow to the right into list 2. Clear out whatever garbage I have in there. And then in any order, doesn't matter what order, I'm going to put these new data points. All right, this time we're going to look at both plot 1 and plot 2. So when you have those in, go second y equals, turn on plot 1, set to the box and whisker, which is the 4th type, and be positive that it says list 1, because then I'm going to go into plot 2. So go back second y equals down to plot 2, turn this one on, again choose the type box and whisker, which is the 4th one, but it has to say list 2 this time. So my fancy dancy color one is going to do the first one in blue and the second one in red. Yours is just going to do one above the other, unless you have a color calculator, okay? List 2, but if it doesn't say list 2, we're in trouble. So it's going to do the same one twice. Yes?
What's the difference between the
If there is an outlier, the 4th one will indicate there's an outlier. If there's not, if there is an outlier and you turn the 5th one on, it will just connect the whisker all the way out to that outlier rather than cut it off. And I don't have an example of that today. I will tomorrow, I think. All right, guys. Do a zoom 9. Oh, I got an outlier. Did I screw something up?
No, I got one too.
Okay, awesome. That makes me actually happy because we changed that data point. We got an outlier this time. Okay. So there is an outlier this time. The first one says that, anybody know what city that is? If we do trace, Los Angeles is an outlier in terms of the ones by the ocean. That's list 1 though. It says list 1. Is there another 6.2? Oh, Phoenix is windy, is very slow winds compared to the rest and not by the ocean. Okay. What can you tell me? Write a couple sentences now in your head. I don't care if you write them down. What can you tell me comparing these? Cities near the ocean, which are the red ones, have a much wider range, okay? The median is slightly smaller. They have more variability, yes, okay? The median wind speed is actually slightly higher away from the ocean, according to the cities we have chosen, and they are much less variability, much closer together, except for that outlier, okay? Any questions about any of those things? All right, we have one question left that we will cover at the beginning of class tomorrow about a cumulative percentile graph, okay? You